This is our 5th session in the Climate and Weather Data for BC Agriculture Adaptation webinar series. If you're just joining now, take a minute to introduce yourself in the chat. Make sure you send it to the panelists and all the attendees. Be great to hear where people are joining from. I see we have someone joining from as far as Egypt today, but most people are a little more local than that. We have a full session today with 3 different presentations and 4 presenters, so I'm going to jump right in. So as I mentioned, this is the 5th in our series. Today we're going to be looking at tools that support on-farm decision-making. All of these sessions, the ones that we've done previously in today's session, will be recorded and they will be available on our website and also the ACARN YouTube channel. So that's bcacarn.com. Even though this is our last in this session, we do have the BC Agricultural Climate Adaptation Research Workshop coming up. This is an annual event. This will be our 5th one that we've held, and this year it's going to be virtual. So there'll be more information coming up soon, but that's happening December 7th to 9th. So there'll be a lot more sessions focused on not only climate and weather data, but also other aspects of agricultural adaptation research, from pest management to soils. Yeah, so stay tuned for more information on that. And then to jump in for today, so we have 3 presentations and 4 presenters. So we're going to be starting off with the BC Peace Agri-Weather Network with Talon Gauthier and Andy Nadler presenting. And then Molly Thurston is joining us to speak about the BC Decision Aid System that's in place in the Okanagan. And then Jeffrey Nemo from the BC Ministry of Agriculture will be presenting on the application risk management tool. So throughout our sessions today, after each set of presentations, we'll have a break for questions and answers. If you can use the Q&A box to type your questions, that will be easier for myself and for Jesse Booker, who's joining us as a moderator, to keep track of your questions. So we'll have a break after each of the presenters to do Q&A. You can also use the chat if you want to make comments as you go along, but please try to focus your questions there. We are recording the session, but if you're typing in the boxes, that won't show up on the recordings. So with that, I'm gonna not waste any more time and just pass it right on to Talon.
All right. Can everyone see my screen?
Yeah, looks good, but just need, there you go, perfect.
Went too far. Okay, so welcome everyone, good morning. And we're gonna do a quick update on the BC Peace Agri-Weather Network and just a bit of, I'm gonna just go through a bit of an evolution of how the network kind of came to be. And then Andy's gonna do a dive into the actual specific tools that are available to producers to use. So we'll kind of do, this is a bit of an overview. And I'm just gonna minimize this here. So it started in 2014. So basically when the Climate Action Initiative first started and went around to all the regions, this access to, accessible and agriculturally relevant weather data was identified as a big gap for our producers in the Peace region. So there was a report then generated, which was done by Weather Innovations and actually completed by Andy when he worked for them. And so he actually identified all of the gaps and looked into, kind of what weather data was available. So then it was decided that we actually wanted to have a project where we actually set up a bunch of stations and got stuff going in the Peace. So there was a project then initiated in 2015 and 2016. And that actually was contracted to Weather Innovations Consulting, and they came and installed a bunch of stations, Andy did, and then they worked on building us a website to access the data. So there was some bumps along the way in the sense that the website that was generated was not particularly user-friendly. You had to enter in a lot of data before you could get access to the weather. So, had to enter in a lot of crop information and stuff like that, which was a little bit of a limiter. So when that project ended, the funding ended, we actually got renewed funding in 2017. And so we decided that we wanted to actually change platforms. It was really expensive with the way that we were doing it before. We needed to find a much more economical way for us to share the data. So we actually built our own website. And we, because Weather Innovations was all the way in Ontario, they only came up once a year to do any maintenance. So we actually had them train a local contractor to do the maintenance locally. And then, so that project ended in 2019. And then we have moved into 2020 where we have funding again. This is back through Climate Action Initiative. And we have contracted Andy to help us just with the building our own website. It's a huge undertaking and there's a lot of stuff that you don't understand if you don't know a lot about weather and the way that the models work and everything like that. So we actually contracted Andy to help us fix some of the glitches that we had, fix some of the user experiences, implement a better forecast system into it, and so on. So this slide is just to give you guys a very, obviously this project has been happening for several years. There's been many, many contributors all in all. Industry-wise, these are local associations that have contributed to this within. And then there's the funding that's all obviously come through, several different regional and provincial sources. So we really appreciate all of the funders that have contributed. So where are we at now? The idea is that, there's current and historical information is available on the website for anybody, any producer or industry person that is needing access to rural Peace Region weather. There's no subscription fees at this point or complicated accounts to prevent access. The stations are set up in several rural communities. You'll see here on this side of the screen, this picture showed where the weather information, where access was before. Now this is what we've increased to. The users have access to historical data, which could be used for a variety of different things, such as crop insurance claims, litigation issues with oil and gas, and it's also been used to assist researchers or government when, developing models or trends. Our regional district emergency management team has access to the information for drought or flood risks, and they've actually added a couple of stations into areas that they were concerned about. And then just going on to what Andy's going to talk about, that there are weather tools and models on the website to assist farmers and producers in making in-season management decisions. So will stop it there and pass it over to Andy to share what those are.
All right, thank you, Talon. Just to confirm, you can see my screen?
Yeah.
And hear me? Perfect. All right. Super. Well, that's great. That provides a great start to where I wanted to go with this. Talon said I'd do a deep dive, but within the few minutes we have, it won't be super deep, but I will do my best. But where I'd like to start is a little bit of maybe it's a bit of a theory foundational just to see where things started. When I look at, say, agricultural decision support tools, for growers, I sort of think of it as a bit of a pyramid, or there's a bit of a hierarchy of where we need to start. And I think the biggest thing is quality data. That's sort of the foundation of everything. The data needs to be accessible. So, first of all, it needs to be, available to whatever platform it is. It needs to be accurate. Now, I say accurate enough because, accuracy is such a loaded term. You can be, super accurate down to the 10th decimal place, or you can be good enough for what your decision is going to be. So I think that's one of the important things to look at, which always comes into play with weather monitoring, because accuracy is usually, the more accurate you are, the more expensive it is, and that could be cost prohibitive. Representative, so things like, and I'll talk about it in a second, how far away is a weather station from where I'm actually trying to look at, from my farm, from my field? Is it even sited properly? There's say forestry stations, things like that, they're great weather stations, but does it represent the field? Does it have the relevant parameters? Do I need hourly data, daily data, which measurements, temperature, humidity, solar radiation, those types of things. And the other big thing, of course, is sustainability. Talon alluded to it with, funding and things like that. It costs a lot to build and maintain a network. So I think those are things that, definitely need to be looked at. And I think the BC piece, as Talon said, it's been really in the works for, since 2014. So it's been a few years. There's been, like she said, some bumps, some learning experience, but I think it's, it's moving along nicely. But so the next step, that data visualization part of it is, getting that data to the user. Is it user friendly? Is it, not just presenting data in the sense of, here's some numbers, but ways to look at trends and things like that. And also, is it mobile enabled, in terms of a lot of farmers are using their phones, tablets, that type of thing. So it needs to be friendly that way. And then where we want to go, sort of that apex, is the decision support part. Is it specific to the sector? Is it relevant, regionally relevant? Is it, simple to use? All those things. The other thing too is, Talon did mention requiring limited user input. I mentioned that too, because the more data you have to put in, from what I've seen, the less likely farmers are to do that, just because it's a lot of work, and the more you have to do, it's just, when farmers are busy, it's probably the last thing they really want to do. So I think it's pretty important. There's one study, a paper from a couple of years ago that I really like, and maybe this is a discouraging way to start. Is the paper says, despite their availability, wide range of formats, studies in several countries have shown uptake to be disappointingly low. So for a guy that works on these types of things, with products for trying to help farmers, it's sort of discouraging to see, for a study that looks at these and says, well, there's not a lot of uptake. So I guess I could see that as discouraging, but maybe I see that as a challenge. And it goes on to go into great detail, and I'm obviously not going to go through these in detail, but there's 15 factors that contribute to successful decision support tools. So like I say, I'll just show these, but there's a lot of factors. Who are your farmers? Age, scale of business, farm type. Then there's most of them are self-explanatory, but things like facilitating conditions. What that means is there internet availability? Is there cell phone coverage? Those types of things. So all things to think about. And then, there's all these core factors: ease of use, trust, cost, habit. So needless to say, there's a lot of things to look at when you're designing, when you're coming up with these things. Just putting out a tool is not enough. It's looking at, who's your user, and then uptake is kind of that first part, but then actual use, does it get implemented? Because these aren't cheap to implement. Weather networks are expensive, so it's one of these things that we really need to consider. So let's start with the network. I sort of put the weather data as being that foundational piece. So if we look at the Peace region, and a couple of stats I find really interesting, particularly for people that are less familiar with the region, it comprises about 32% of BC's total farm area, produces about 90% of the grain, 95% of the canola, yet it's only 8% of BC's farms. So what that tells us is the average farm size in the Peace, it's about 1,400 acres versus the BC average, which is 327 acres, to be exact. But you look at the scales there, much larger farms compared with the rest of BC. So what that means, there's more land to manage, and it's further spread out. Not all the farmland's going to be within, a kilometer or two of the farm. It's going to be, 20, 30, 40, 50 kilometers away, which is important when you're trying to manage land that is far away. So if we looked at the weather data, and this goes back to the initial gap analysis, if we look at Environment Canada, well, there's 3 stations in the whole region. If we do the math for farmland, it's about, 1 station per, 735,000 acres of farmland. Not very good when you look at that. We can look at some other networks, and there are other networks in BC, and it's actually quite integrated nicely with the climate-related monitoring program. But if we look at some of them, we need to look at, are they applicable? One of the this is just taken from the study. I know you can't read that very well, but if we look at the elevations of the stations, these lower elevations being where the actual agricultural land is, a lot of them are at high elevations, less applicable to agriculture. So that actually limits quite a few of them for use. So needless to say, there's gaps in monitoring. So what happened, and then this is where Talon was talking about the actual network. The Peace region put in a lot of weather stations. So there's actually a pretty amazing network throughout, 22 weather stations, near real-time reporting. The data is freely accessible to anybody on the website. I'll show that later if you don't know it. And it's recording some basic parameters: temperature, relative humidity, rain, wind speed, direction, all the parameters. So the website itself right now, and this is actually, we've done some design tweaks in the last couple of weeks. So this is where it's going. It's really turned into kind of a nice, aesthetically pleasing look in terms of being able to see the information fairly easily. You can get what you need in terms of either the basic information, map form, or viewing. But then we go into the decision support tools. So things like right now, wheat midge is one of them. There's sort of a limited slate of decision support tools at this point, but right now there's the wheat midge model, and it's based on some research from several years ago done throughout the prairies, but it's still widely used, looking at degree days, how it contributes to the emergence of midge, and then for management practices, farmers can use that. The other one that's currently offered is growing degree days, so the users can calculate GDD based on different thresholds, looking at crop development, those types of things. Right now, it just goes to growing degree days. So if you want to know how does that relate to the development of my barley or something, that's not included there. So that's sort of that next step. And then there's also a fusarium head blight model, which looks at temperature and moisture for the development of fusarium. So where is it going? Well, current functionality, since over the last few years, the weather data is there. So, this was based on, as I mentioned, the weather network, stakeholder input, gap analysis, and then the actual physical weather network being established. And it shows things like current conditions, daily, hourly forecasts, historical weather, data export. And I sort of see those as kind of that, the base products. Then there's the visualization. So the maps, charting, diagrams, just different ways to interact with the data. And then the decision support side, getting to those derivatives, the growing degree days and the feels like, those are, just a kind of couple of the basic ones. And then decision support. I mentioned the wheat midge, the fusarium head blight, and then the features in terms of favorites. You can bookmark stations, there's alerts, notifications, but then where's it going? This is sort of where it's at currently, or where the next steps are. Point-based forecast, I won't get into it too much, but currently it's using a regional type forecast, and we know that's, things differ within the regions, so that makes a big difference. Visualization side, improved user experience, mobile friendlier. Derivatives, summaries, so what was my rainfall for this period, growing degree days, percents of normal are really nice to be able to compare, say, a period, to know how does it compare with with a 30-year or 10-year average. Am I wetter than normal, colder, drier, that type of thing. And then this is currently underway just in terms of some stakeholder feedback. The next little while, what are the next steps, growth stages, sclerotinia for canola, heat stress, alfalfa weevil, trafficability, spray advisories, just some of the options right now in terms of, what will be the next things to be added, what would be the most useful to the growers, to the industry, that type of thing. So those will be the next steps. And finally, things like reports, data sharing to Farm West specifically. So just sort of where it's going. So there's a very quick snapshot of where things are at, what's been done, what's going to be done. Overall, it's a really exciting program, and I think I'm happy to share this because it's it's really interesting what's going on in the piece. And I guess where we'll end off is there's more to come. And I thank you very much. And I'll pass the floor over to the next person.
Thanks, Talon and Andy. I appreciate you had not a lot of time to report out on a big undertaking. We'll just pause here for a few questions. So if people have questions, type them into the Q&A. There's a few that have already come up. This first one I'll direct to you, Andy. The DSS tool requires good data. How do you error check and eliminate obviously erroneous data?
Yeah, excellent question. There's some very basic QC, most of it's human involved. So looking for anomalies, things like that, which is obviously not the best. Well, it is a method, and it's sort of maybe more of a last resort, but that's one of the pieces that needs to get implemented is even a basic QC, some coarse filters, stuff like that. So short answer is it's in the works, getting there.
Yeah, always a challenge, right? I also have a question on the number of weather stations. So I think this was mentioned, but how many weather stations are part of the Pete's Weather Network, and are some of those grower owned that are sharing data into the network?
Talon, do you want to?
Yeah, I'll take that. So there are 22 stations, as Andy mentioned, in the network. And so some of those are stations that were already grower owned that we actually asked if they would mind sharing the data. And then the rest of them, though, are stations that were actually bought through the project. And then they are all pretty much all set up on grower farms. Some of them are set up at regional landfill areas just because we weren't able to find a grower, or we needed, some of the challenges was being able to get them into either internet service, or we had to actually attach a cellular service to them, and which was quite a bit more pricey. So we didn't try to do that too many places, but some of the far areas we had to.
Great, thanks for that answer. So we'll move on now. Thank you, Andy and Talon. So Molly's going to be up next, but I just will mention that we were just discussing in the chat that after this session, I'll follow up and share the slides that you both shared today. And also I can share your contact information. We do have people joining from lots of other parts of the province and the country, so they might want to get in touch with more specific questions on setting up a regional network. So thank you, and we'll hand it over to you, Molly.
Great, thanks, Shauna. Can you hear me and see my slides all right?
Yeah, looks perfect.
Perfect, thanks everyone. Good, so good morning. My name's Molly Thurston. I'm calling in from the Okanagan, where I work as a horticulturalist, also as a tree fruit grower, and on contract with the SIR program managing the BC DAS system. So today I just wanted to give an overview of what our project has been. We're reaching the end of a 3-year pilot project for this decision support tool, and also just wanted to delve a little bit into the tool itself, just to give everyone an idea of what it is that our growers are seeing when they open the tool. And I think this will build a lot on what Talon and Andy had discussed. I really liked the pyramid that Andy provided, because a lot of the concerns and sort of sustainability of this project really does rely on the base of that pyramid. So I'll talk about that at the end of my presentation as well. Great, so just going into what is the decision aid system itself. So this is an online support tool that was developed by Washington State University to support integrated pest management in orchards. And it was launched in 2007. Basically, Washington had looked at their industry and had seen the extension service being decreased over time and not being able to do as much one-on-one extension with tree fruit producers, as well as a real increase in the complexity of pest and disease issues that were seen on farms and in the spray programs that were required to manage both resistance in pests and diseases, as well as the changes. At that time, we were losing a lot of our organophosphate products and starting to get into some very specific control sprays for insects in particular, as well as diseases, and needing to really get into the degree days and the timing and the life stages of the pests in order to control them appropriately. So this project had been established in Washington State. We'd been very interested as an industry here in British Columbia because we do share a lot of similar pests and diseases as well as climate. And we really liked how the local climate data was integrated with the IPM recommendations that were available on screen for the producers. So when the Agriculture Climate Change Adaptation Project had come through the Okanagan and in consultation with the industry, the DAS system itself was identified as something that we were very interested in. And so we already had an established weather network here in the Okanagan, Similkameen valleys with the Grower Supply Weather Network. We had 21 stations, basically from the border all the way up to Salmon Arm. And we were already running some of the degree day models for insects, codling moth in particular, along with diseases such as scab and fire blight. However, the system was clunky. We were having trouble with delivering that information out to all growers in a fast and effective manner. There was a lot of handwork that was done, doing calculations in the background, a lot of complicated spreadsheets that would be put together, and the recommendations were being delivered by phone or over a Codaphone message that was recorded to growers or put out into a newsletter. So not very time sensitive. And with the changes that we were facing with increased rainfall in the spring and changes in humidity as well as temperatures, there was a real pressure to try to get on top of some of these models and provide that information in real time to growers. So BCDAS came about as a cross-border collaboration between the Sterile Insect Release Program, Washington State University, and BC Tree Fruits Cooperative, who owned the Weather Network. We've had a ton of support from industry. The BC Fruit Growers Association has been on board with us, along with experts from Agriculture Canada and the BC Ministry of Agriculture. And those experts really went into the information, looked at the models, looked at the recommendations, and vetted them all before we launched the program. So a lot of kudos to our experts in our industry for supporting the information to make sure that the recommendations that you'll see when I do the demonstration are really the best that we can have for this area, and rely on our BC Integrated Pest Management Production Guide, which has also been launched online, which was a key part of this project as well. So as mentioned, we're at the end of the 3-year pilot, and we're looking at where we'll go from here. But to give you an idea of how the system works, I just want to say briefly that BCDAS is collecting daily weather data from our stations. The network, as mentioned, is 21 stations with Grower Supply, as well as almost 8 stations that Environment Canada runs in this area. We run pest, disease, and horticultural models, and the information also is provided in as near to real time as possible for growers, and is available on mobile apps as well. Well, it's not an app, but it's a mobile website that you can access quite well on your phone as well as off the computer. And we also list time-sensitive stories or how-to messages on our webpage itself. And that's really to try to draw growers to what are some of the things that are happening in industry that they need to be aware of, as well as to offer some help and support. So each of the growers can log into the system, creating their own unique profile, choose a weather station that's relevant to their area, and select their own models. We're currently running 18 insect disease and horticulture models, and I'm showing you a couple examples here where the grower can choose which crops they have in their orchard: apple, cherry, pear, and soft fruit, as well as a number of models for insects, some bloom models and fruit growth models that relate to apples only at this point, and a number of diseases that are available on the system. There's more models being added all the time, and we're working closely with Washington State University to help to launch some of the models that are being locally developed as well for pests that are relevant to us. So when it comes to the actual recommendations, what can BCDAS provide to the growers? Basically, we cannot tell a grower if a spray is needed in a specific orchard at a specific time. However, BC DAS can recommend a general crop stage or a timing based on the information that the grower inputs for their orchard, as well as recommend a number of products that are available to the grower. And those management decisions of which product to choose itself are not going to be given by the BC DAS system. It's going to pull up a list, as you'll see, and the grower and their pest manager really have to then go out into the orchard, still do the scouting, still make the observations, but then come back to the tool in order to use that information. So to give a real brief sort of introduction of how we would use this tool, I wanted to talk specifically about scab. And the reason this disease is so relevant for our growers is it's very much a climate-related disease. We require a certain amount of temperature as well as leaf wetness, both of which are being monitored by the climate stations in the orchard in order for that disease to be active and to infect. And so infection is really important to get on top of. And these are some photos of ambrosia apples, beautiful, extra fancy apples. These were destined for export, but unfortunately you can see these dark scab lesions on them. And so this is very much an economic pest or a disease within our industry. So as a brief overview of Scab 101, because I see some colleagues online who are from orchard backgrounds, but lots that aren't. So this is a fungal pathogen. It's Venturia inequalis. The pathogen itself overwinters on the leaves of the apple, and this is an image that I took just last week while picking in the ambrosias. And you can see the scab lesions are formed there. When the leaves fall off the tree in the winter, those lesions will stay on the leaves and be on the orchard floor. In the springtime, the lesions, basically the ascospores, the spores themselves, will be released from those lesions and will end up being blown up or splashed up into the tree. And so with rainfall and leaf wetness, humidity, basically if we're at 10 degrees Celsius, it would take about 11 hours of wetness for an infection period to occur. And as the temperature raises to 20 degrees Celsius, it would be something like a 6-hour wetness period. So that's what we're monitoring within the model. And we have two spray options as growers. We can choose to put on a protectant spray that would go on in the early stages of growth from green tip through to the petal fall period, where we would try to apply the spray ahead of an infection period coming. So looking at the weather forecast that's provided on BC DAS, looking for an opportunity to apply before. Or the other option is an eradicant, and that's where post-infection period, we would go back in with a systemic fungicide and try to provide kickback activity to cover that infection period. However, it's extremely time sensitive. Each of the chemicals has a different window for application, and each of these chemicals are also at high risk of resistance developing. So we need to make some management decisions. When you go into the model itself, and I open this one for my area in Winfield South, I would enter in a date when my green tip started in my orchard. And from there, then I would have very easily described conditions for the orchard, which would tell me whether or not there's been a scab infection period indicated for the orchard, which crop stage I'm at, and give me some management recommendations. So if I'm looking at the forecast and I can see for my organic orchard that I need to spray, I have the option of putting on a sulfur spray as a protectant. Then if we go into an actual scab period, and here I've pulled one up from the past, this is where it's a really clear indicator to growers that 7 hours ago we had an infection period that occurred. So now I'm going to be given a different eradicant recommendation so I can go in post-infection and do a treatment. So again, I'm offered the option of lime sulfur because it's an organic orchard, not a whole lot of options. But there's other options available to our conventional growers. And that's the great thing about the DAS system is we have both organic management recommendations as well as conventional recommendations. The other thing I really like about how the information is displayed for our growers is there's a chart here. So if you're in a hurry, and farmers we often are, especially when the rains come, you can take a quick peek at the chart to have an indicator in colored bars as to whether or not there's been an infection. So the yellow bars will build up towards an infection, and the red bars indicate to us very clearly that an infection period has occurred. You can get really technical and get way down into the data tables and get into the nitty-gritty of hours of infection, what the actual temperatures were, how many hours are required still before the infection period occurs. And all of that information is here, and growers can really dive into that, as well as dive into the various products and the pest itself right from the DAS system, which will bump them back into the production guide. Here, just for an example, is a conventional management recommendation where a treatment was required. And so it pulls up a list of eradicants, and this is where the hours for kickback are indicated. So again, very clearly to growers, you can go in and say, okay, I know that I've had this infection period that occurred 7 hours ago. What are my options for spray? And if I'm looking at the forecast and I see that there's 3 more days of rain, how am I going to fit that in? So I can look at some options that would give me kickback between 0 and up to 72 hours. So again, pretty informative for our growers and provides a lot more information in, again, essentially real-time format to those growers. So just to wrap up briefly on where we're at with the status of the project, and we wanted to look at it, just how many growers have used the tool and how is it being effective. And to date, we have 317 of our tree fruit growers registered for the system. We've had in 2020, 144 active users. So those are people who are signing on more than just once. So these are people that are coming into the system, some of them daily, some of them a couple times a month, or some of them during the critical time periods around bloom to use the system. Our top 5 stations tend to be in very large orchard areas with lots of concentration of both apple and cherry orchards in Summerland and 4 areas of Kelowna. As we get further into the South Okanagan, our uptake is not quite as good. However, we do have a higher concentration of soft fruit growers, and we don't have as many models available to those growers. So we're continuing to do outreach to our growers, lots of online meetings this year, obviously, although we did present in conferences in the spring, and we're able to show growers how to use the tool, which again has given growers more, I think, hands-on experience and help growers with sign up, because again, as Andy mentioned, the input of information into the tool is often the place where we lose a lot of our growers. And so we've really tried to simplify that, as well as offered a number of help videos to walk growers through those very simple steps of setting up themselves on the tool and getting themselves going, so that then they can get familiar with the information that's there. And what's ahead, as mentioned, we're at the end of our 3-year pilot project. We do have very strong support from the industry to continue this project. And we do have good support as well from WSU, as well as SIR, to continue with the renewal of this project. The extension climate, again, in British Columbia and the tree fruit industry has changed significantly over the recent years. And there is just a strong support from both horticulturalists as well as growers to keep this information relevant and available. And again, as we talked about in the previous presentation, so much of this relies on high quality weather data. And at the current time, we do have a very good weather network established. However, that is one of our vulnerabilities going forward, is we want to make sure that that weather network remains secure. We want to make sure that it covers the geographic areas that we are growing tree fruits in, and that the quality of that data continues to be very good. And we've been very fortunate in working with WSU, because they have done a lot of the background quality control on our data, and it has certainly improved the output to our producers. So as we expand our tree fruit production into other geographic areas, and certainly we're starting to see a lot more interest in the Kamloops area and planting cherries up into the North Okanagan, as well as a huge expansion of the tree fruit industry in the Creston Valley, Grand Forks, Midway as well. So we've had a lot of interest from those areas to expand our geographic coverage and potentially to roll those tree fruit growing areas into DAS going forward. So that's an exciting point for our project. We're definitely looking forward to continuing our collaboration with our partners on this project and continuing to deliver a really high value product to our growers. So I'll wrap up there and just leave it open for any questions. Thank you.
Great. Well, thank you so much, Molly, for that informative presentation. There were a few questions that came up around the uptake and the percent of growers that have began to use the tool. So specifically, of those 144 very active users, what percent roughly is that of the total growers in the region that you're focused on?
That's a great question. And I think we need to probably define the users there. The usership is probably split about 1/3 industry, government, and researchers, and then the other 2/3 are active growers, I would say. And so the overall percentage of growers in the valleys that are using it is still, I would say, well below 50%. You know, we had pegged it at about 33% last year. We've certainly had some uptake there, but I would think we're probably in and around 40%. Again, some of the grower users are from outside of our valleys because we do have interest, you know, certainly from the Kootenay boundary area. So we are getting a few users that are tapping into the system at least to access the management recommendations, even though they're not able to use the climate data exactly for their farm. So I'm estimating at about 40% usership at this point.
Great, thank you for that. There also was a question, and this is something you touched on, is interest of using this tool in other regions and the applicability. So specifically, someone was asking if this would be applicable for Southern Vancouver Island. But maybe you could just speak in more generally how it could apply to other regions and what are the limitations for other regions using this tool.
Yeah, I think the management recommendations definitely can apply for other areas. And I've personally encouraged a lot of my clients in other areas to use those recommendations. Where it breaks down is probably in the actual growing degree days. So unless you're able to access a weather station in your geographic area and as close to you as possible, and then interpret your growing degree days and relate those to the management recommendations, that part is going to be really difficult. So if you're using Farm West, for example, you can also see growing degree days there, and you may be able to use those and look at a station that relates in the North Okanagan or the South Okanagan, and try to kind of pinpoint the general timing. But it is really, you know, where we talk about time sensitive as well as accurate, it is important for those growing degree days, because with insect development, for example, you know, a couple 100 days makes a huge difference in where we're at in that life cycle. And certainly when we're talking about scab and fire blight that are looking at rainfall in combination with temperature, it's important to have that local regional data available. So, you know, when we've looked at expanding the network, we again really want to be in areas close to or on farms that are growing those commodities, so that we can get as much accuracy in those recommendations as possible.
Great, thanks for that, Molly. There are a couple of questions still left in the Q&A box. So as Jeff is presenting, maybe you could just answer those, or we can follow up with people afterwards. But Jeff, I want to hand it over to you so you have time for your presentation as well. Thanks, Molly.
Thank you. All right, is that coming through there, Claire?
Yep, looks good.
Great. Okay, thanks. So I'll be talking about our BC Application Risk Management Tool, or what we're trying to coin it as ARM. And so I'm Jeff. I work with the Ministry of Agriculture as a nutrient management specialist. And really this is a decision tool that's intended to use weather data in order to assess on-farm conditions and predict the potential for runoff on farms after nutrient applications. So yeah, similar to Molly, I think I'm really happy to kind of follow that intro from Andy that really built up what it is about a tool that will actually get used, or how we can kind of encourage people to make use of all of this work that we've put into some of this. So to kind of sum up what ARM is, really it's just a tool to try and answer this question. Is it going to be a good time to spread manure on this field tomorrow? And there's a lot wrapped up into that. And this tool will assess a few aspects around manure or nutrient source spreading that someone might want to be concerned about. So the kind of reasoning behind this, there's two sides. Really, if you're going to go to the length or the effort of spreading manure on the field or fertilizer, you know, you want to keep those nutrients on the field. And all of that is we want to encourage better nutrient uptake. If you're actually using purchased input, whether it's a purchased input that you're applying at the moment, or whether it's across the entire year you're purchasing inputs, if you're putting nutrients down, it all contributes to your overall nutrient management, and we want to make sure that it's actually staying put and not wasted. It also can, if you keep those nutrients in place, whether it's on the field or just evenly distributed across the field, you'll end up with better quality of the crop itself. And one of the big drivers behind this is the other side, which is actually about environmental protection. And so runoff of nutrients off of the field can result in water contamination of our surface waters. And so that's something we're trying to really avoid. And this tool is designed to try and support growers to make sure that when they're applying, it's the right time to prevent nutrient runoff. And so, as I mentioned, it's really a tool to assess runoff risk. It's following the application of manure. And here it's a real-time decision aid, and it provides field-specific information based on the input from the grower. And just wanted to point out, this isn't, I can't take credit, or our ministry can't take credit for developing the tool. So a big kudos to Nicole Embertson and the Whatcom County Conservation District in Washington. They put a lot of time and effort into developing the process, and then also ground truthing and sort of seeing, does this tool actually work at the environmental outcome that they're really driving for? And so it was really great to be able to borrow from their experience and really the entire structure of how this thing works and implement it here in BC. The tool was piloted here in BC and then officially kind of broadly launched in 2019. And I'm happy to be kind of filling in today, but there's several others within our ministry as well that have done a lot of work on this project as well. And so from those early stages of piloting, Dave Poon, as well as Josh Andrews, our nutrient management technologist, have done a lot of work getting the ARM tool up and running for growers to be able to use today. So what it is, it's based on factors that affect runoff from agricultural fields. And so there are really two of the big categories there. A real driving force behind that is precipitation. And so if you go out and you spread manure, if it's going to rain a lot the next day, those nutrients or the manure itself is going to start moving around, and that's what we want to try and avoid. And so it incorporates 24 and 72-hour weather forecasts. And then the second part of the tool is all about, okay, the field where you're actually looking at spreading, what are the conditions there? Because aside from just the weather that's coming in the future, there's existing soil conditions that can affect how likely it is that runoff will occur. And so things like the moisture content of the soil type itself, whether there's a crop standing in that field or not, all of those things affect the likelihood of runoff. And the tool incorporates all that to try and generate an overall assessment for runoff risk. So as I mentioned, there's two components, that precipitation and then the field specific stuff. And so the tool kind of is structured that way. There's at the initial sort of phase, a precipitation map that the grower can interact with to figure out what the forecast is. And then that pushes them afterwards into a field questionnaire where they go through and look at what's actually going on the site where they want to apply. And so overall, this is going to give the producer a risk of nutrient loss if they go ahead and spread on a given day. And the idea here is that if you want to try and plan for the following day or somewhere close in the future, because certainly as time goes by or as we look at sort of further and further ahead in planning, our accuracy of weather prediction really goes down. So we want to try and encourage people to use this as close as possible to when they're actually planning to spread. And a strength of this tool is it provides a fairly standardized experience for all the growers in the region. So they're all using, if they're comparing assessments, they're using the same tool, and it allows people to understand the factors that actually influence runoff risk. So aside from just telling people whether it's a good time or not, by using the tool, it can sort of subtly encourage people to think about the conditions or the practices that they're actually using on the field that might increase or decrease their risk of runoff. So the first part of the tool is a precipitation forecast map. And so I mentioned it's got 24 and 72-hour precipitation for areas of the province that receive a lot of precipitation over winter. So fall and winter, October, right into winter, areas that get a lot of precipitation. have been included within the forecast map at this stage. And we've broken those regions down into smaller shapes on the map that someone can click on, that each of those individual areas has a very similar weather pattern based on the climate normals that we were able to obtain and model for the province. And so if you look at this map here, gives you a sense of the building blocks of what we actually use as a precipitation map. And so this is the modeled climate normals. And really what we were looking for is regions on here that essentially have really similar coloring, indicating that within that region, it's fairly consistent weather reporting through that winter period. And then once we saw a consistent region, that was blocked off as a shape that we would then pull a forecast for on the map. And so the forecasts that are generated in ARM are actually coming from Open Weather. It's an open source weather and forecast aggregator. So it's actually using a bunch of different information to provide this weather forecast. And so it pulls from Canadian sources and other agencies to provide a weather forecast. And this is what it results in. So this is the front page of the BC ARM tool. And the idea here is the initial precipitation contribution to runoff risk is coded. So as you can see on this map, this was kind of an interesting day here a little while ago, where we saw across the region quite different outlook for runoff risk due to precipitation. So the color coding is to kind of drive back to some of those principles that Andy mentioned, is we're trying to provide as simple a decision-making process as we can. And so really green means go, red means stop. If you see a lot of precipitation coming in the forecast, that should be an indication that you don't want to spread on the following day. So that's the first phase of the tool, where a grower looks and then sees what the precipitation contribution to runoff is. And then once they've actually picked a date to apply, they can click on the map to find out what the precipitation forecast is. And then if it's good enough that they think it's worth continuing down to the field assessment, they can click on the ARM worksheet portion of this, where it bumps them into the field specific questionnaire, where they proceed to assess the conditions on their field itself. And so ideally, the farmer's doing this for each field, or if they're looking at a group of fields that all have similar conditions, they can do them all at once. But the questionnaire that's shown to the grower is really designed to try and assess factors that affect nutrient loss. And we pull from the mapping portion the precipitation forecast into the questionnaire. So that step is already done for the grower. All they need to do is answer some of the field-specific questions. And so here's an example of something that we'd be asking the grower. And so a really important driver in field runoff is the actual existing moisture content of the soil. Because if there's already a lot of water within the soil, it won't take much precipitation to start driving overland movement of water. And so here it's essentially a series of questions on this worksheet, and the grower just picks the one that applies to the field they're looking at spreading on. And so this is one of the areas where we've done a lot of work trying to figure out, okay, how do we simplify or make this process as user-friendly for growers as possible? And so when we work at developing these tools, we show these questions and the tools to growers to try and get their feedback on, does this make sense to you? Are these categories easy ones that you can quickly pick from? Because if it were broken down to much smaller sort of level of detail, it starts to verge into the impractical. And so aside from just the category breakups, here we're providing some really descriptive wording in terms or sort of real language that someone can actually appreciate, aside from having to go out there with a moisture meter to try and determine whether they're at 90 or 91% moisture. And so the tool will provide for each question a rating of how that contributes to overall runoff risk. And so here you can see if we're at sort of lower soil moisture ranges, it's contributing a small amount, or it's contributing less to the risk of runoff in this situation. The form itself is also sort of responsive. So if you fiddle around with the ratings, and so in this case where someone's bumped up the soil moisture content up to 90 or 100%, it'll show that this has actually increased the risk of runoff quite a lot on this field. So after answering a series of those questions, the risk for runoff that's related to precipitation and all of the responses on the field questionnaire is summed up in a final scoring, and really it just comes up down to sort of a low, medium, high risk scenario, and that's what's provided for the grower for that field. The risk of spreading on a given day related to runoff. And the tool includes also a portion where the person can save the questionnaire, so that at the end of the process they can document, okay, before I went out and spread, I did my due diligence and I checked to make sure that the conditions were right, and it was really unlikely that any manure spread on this date would flow off the field. And so that's what we're trying to really drive at here, is that the tool can, aside from just ensure that if you are going to go out and spread, that you actually keep those nutrients on the field and get good use out of that, because that's kind of driving at the bottom line of keeping the nutrient sources where they need to be, and ensuring that overall there isn't loss to the environment. And so if you're able to document that within your farm records, it can help show that you've taken care to ensure that the nutrients stayed where they should. And so that's essentially the process that someone goes through on ARM. And the other kind of point of the tool is that aside from that sort of documentation of your farm practices, by actually working through the form, it shows you the different practices that you can do. So depending on how you spread or the setbacks that you use on your field, those there's questions within the ARM questionnaire that relate to that. And if you're going through that and seeing that by changing some of those practices, it might actually reduce your overall risk and sort of push you towards, maybe I could spread more often if I adopted some of these practices. The tool kind of is ideally gradually shifting that perspective, or gradually educating on what someone can do to reduce the chance of having manure end up in surface water. So overall, it's a decision tool that allows someone to decide, okay, should I spread or not? But it also provides us with a pretty unique way to get outreach out to growers that are spreading manure and fertilizer as essentially an extension tool for us as well. So that's kind of my really brief overview of what the tool is. I'm happy to take questions if anyone's got any about the tool itself or how it gets used on farm.
Thank you for that, Jeff. It's a great overview of a very user-friendly tool. We do have a couple of questions for you. Molly, there's also a couple more questions on the DOS that have popped up in the Q&A. You could type and answer those, that'd be great. And Jeff, for you, I'll start with this question around the promotion of the tool. So the question is this tool being promoted to local governments concerned with eutrophication of lakes? And they give a couple of examples of where that's an issue on Vancouver Island.
Yeah, local governments is actually a really good point. We haven't done a huge amount of outreach with local governments. Our main sort of, I'd say, promotional push has been to try and encourage adoption among growers, but it's a good point that it's a group that we could reach out to as often those folks are in communication with individual growers in the community. So it's definitely something we can look at as getting this URL essentially that you're seeing on the screen there into their hands. The tool's been live since 2019. We've gradually been bringing more and more of it into our own ownership as far as having the tool under the control of BC Gov. But yeah, we'll can follow up with that.
Great. Okay, and another question for you is, does the ARM tool work with other models for nutrient management or farm management decision support tools? So as an example, the series crop models work in conjunction with DSAT models.
Yeah.
Have a similar kind of compatibility?
Yeah. Short answer, no. It's standalone at the moment. And in a way, so the ARM tool is really about making that in the moment decision of is it the right time to spread, whereas a lot of other nutrient management decision making tools are on the broader planning perspective, and so our ministry has other decision making tools along the sort of questions of, okay, how much should I spread, or if I know I need to provide this much across the entire year, when should I split that up? So those types of questions largely are to do with, you know, the nutrient availability and the crop demand, and this tool is more about sort of ensuring that all that planning you did before actually is worth it, and you're using it at the right time. So at the moment, there's no connection of sort of, if you use ARM and assess risk, does it keep a record of that and input it back into another tool? It's not something that at the moment we do. Would be kind of interesting to see how that might play out. It's always, nutrient management is always a lot about planning, but at the end of the day, there's the record keeping on the part of the grower to actually sort of indicate, okay, what actually did happen, as opposed to what did you plan to do, is, okay, on the farm, what actually took place, and that's what really drives planning for the next year. And that requires a lot of data on the grower's part. And as we've heard kind of mentioned today, it really is a challenge to develop tools that people can quickly enter data into and get a valuable response out of. And so I think we always walk a very fine line between a user-friendly tool that someone will buy into and quickly use versus what we want to do, or what we see as, you know, this is really interesting, would love to incorporate XYZ into the tool and see how it affects all the other sort of nutrient management considerations. But yeah, we've had our own share of getting a little lost in the weeds with some of our tools and making them, you can push them into a less friendly zone, and we've had to pull back at times to make sure that the tool actually gets buy-in and will be usable.
Great, thanks, Jeff. I think in the interest of time, we will follow up on the last questions. I'll just have my presenters stay on and answer a couple of those by chat. And we'll let people end the session now. But yeah, thank you everyone for coming today, and thank you to all of our presenters for rising to the challenge of fitting your presentations into such a short time. It's been a really useful suite of presentations and some great questions as well. So thanks everyone for participating today.